Alright, problem number 1. We have a product of 4 to the 7th times 5 to the 17th. And if we were to write that out as an integer, how many digits would that integer have? Okay? Well, let's just figure out. Now we have to deal with these exponents, so let's make sure we know what an exponent means. Right? So the 4 to the 7th just means 4 times 4 times 4, and I'll say dot 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 times 4 7 times, right? I could write all 7 pretty easily, but I'm just going to write it this way. Okay? And I'll put this in parentheses. And then 5 to the 17th just means 5 times 5 times 5 dot 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 times 5, and that is 17 times. Right? So we have 17 fives and 7 fours, but we could actually rewrite this as each one of these 4s could be written as 2 times 2, right? So we could write this as 2 times 2 times 2 times 2, right? And every one of these 4s is going to give us 2 2s. So in this list, if we broke each one of the 4s into 2 2s, then we would have, whoops, writing this backwards. We would have how many 2s? We would have twice as many, and so we would have 14. We have 14 2s, and then we'd still have the 17 5s, right? Just like we do up above. And the key to this problem is to recognize that you can pair 2s with 5s and get 10. So how many 2s can we pair with the 5s? We've got 14 2s and we have 17 5s. So we can take all 14 of these 2s and match them up with 14 of the 5s, and we'll get 14 10s. Or we could write it as 10 to the 14th. Okay? And that gets rid of, or that takes care of 14 of the 2s and 14 of the 5s. But we've still got 3 5s left over. So we'd have 5 times 5 times 5 times 10 to the 14th. Okay? That's the key to the problem, is recognizing that you can, multiplication is commutative, which means you can pair these numbers in any order you want to. So so the key is to recognize that anytime you multiply 2 times 5, you get a 10, right? And 10 times 10 times 10, you just keep adding zeros, right, to a 1. And then we have 3 5s left over, and that's equal to 125, right? And we can actually write this in, it's not necessarily, well, it's sort of like scientific notation. 10 to the 14th, right? I guess the only reason I say it's not scientific notation is that scientific notation usually has, one number before the decimal point. So scientific notation would actually be 1.25 times 10 to the 16th. But we can write this as 125 times 10 to the 14th. And you can see that every time we multiply 125 times 10, we're going to get another 0. So this number is essentially 125 with 14 zeros. So the answer to our problem is that we have 14 zeros and then 3 numbers in front of the 14 zeros. So we end up with 17 digits in the expanded integer. All right? So that's the answer.